Anthony has 63 toy cars and 84 toy trucks. He wants to divide them into groups that contain the same number of vehicles. Also, each group must contain the same type of vehicle, either a car or a truck. What is the largest number of toys that we put into each group? Okay, so two things to kind of point out here is one is we want to have the same number in each pile, and then the other, or in each group. And then the other thing is we want to know what is the largest number of toys that can be put into any one group. So when you see that, like we're looking for the largest number of, you should be thinking about a greatest common divisor. So that's telling me look for my GCD, greatest common divisor. Okay, so now we have 63 toy cars, and we also have 84 toy trucks. So we got to find the greatest common divisor between them. There's more than one way to do this. So if you have another method for getting at the greatest common divisor, then you should go ahead and use that. So I'm going to start breaking them down. Any two numbers that I'll divide into 63. So I'm going to start with 9 and 7. And then 7 is a prime, so we stop there. But 9 can keep going, 3 times 3. And now these are all primes, so I've got 3, 3, and 7. Now with 84, again, you can start with any two numbers. You could do 2 and 42. I'm going to start with 4 and 21. 4 can be broken down further. That's 2 times 2. And 21 can be broken down as 3 times 7. And all of these are prime. So 2, 2, 3, and 7 are prime. Now because we're looking for the greatest common divisor, we want to know what's the largest number that'll go into both of these evenly. So notice that they both have a 3 in them. So we know that 3 will go to each. This one has a second 3, but this one, the 84, does not. So I can't use another 3. 7 goes into both of them. So, and that's it. This is like 2 goes into 84, but it doesn't go into 63. So 3 and 7 go into both. So my greatest common divisor between 63 and 84 is going to be 3 times 7, so it's 21. That means I can have 21 toys in a stack or in a group. Two toy cars race around a circular track, both going the same direction. One car can travel around the track in 210 seconds, the other travels around in 315 seconds. If both cars start at the same place, how long will it be for them to meet at the same place if they continue to race? So kind of think of it this way. So one car, like I said, he goes around the track all the way around, takes him 210 seconds. The other car, he's going to go all the way around the track, same track, but it's going to take him 315 seconds. We want to know when they're going to meet up again. So they may have to go around the track several times so they can meet up again. So like a very, very simple example, like if the first car, he can go around the track in 1 second. So that's where he's going to be after 1 second. But let's say the other car takes 2 seconds. So after 1 second, he's here. And then after 2 seconds, he'll be here. So it would take 2 seconds for them to meet up again. So that's what we're trying to do. Okay, so what I need to do is find out when these two times are going to sync up. So we got 210 seconds and I got 315 seconds. And I got to find the least common multiple between them. Least common multiple. Oops. So between 210 and 315. Now if you have another way of doing this, finding the least common multiple, that's fine. I'm just going to show you one method here. So 210, and then I have 315. I'm going to break them down to the product of their primes, just like we did sort of with when we were trying to find the greatest common divisor. You can start with any number. So with 210, I'm going to start with 21 and 10. And then you want to keep going until you get your prime. So 21 is 3 and 7, 10 can be 2 and 5. And now 3, 7, 2, and 5, all of these are primes. Now I do the same thing with the 315. Let me move this over here a little bit, actually. So let me do the 315. Again, any two numbers I can start with. I know since it ends in a 5, 5 will go into there. So 5 goes into there 63 times. And now 5 is prime, so I can stop. 63 goes 9 and 7. 9 is 3 and 3, and then 7 is a prime. Okay, so I had to find the least common multiple. So the least common multiple has to contain all of these numbers. And it might contain some from both, but it's got to contain everything that's on here. So my least common multiple has to have a 3 in it. It has to have a 7 in it. It has to have 2. It has to have a 5. Now I come over here, the 5, I've already got the 5, so I don't need to include it again. I have the 7, I don't need to include the 7 again. But notice that I have 2 3s, and I only have 1 3 down here. So that means I need to include another 3. Right? Or if you thought of it as being 2 times, 3 squared times 5 times 7, that's fine, same thing. I'm multiplying all these together and I get 630. So my least common multiple is going to be 630, and that also means it's going to take 630 seconds for these two vehicles to meet up again at the same place on the track. Consider the 6-hour modular 6 clock system under the operation of clock addition. So we're supposed to go ahead and complete the clock addition table. Now notice that this is a 6-hour clock, so it may be helpful to go ahead and actually draw out the clock. Okay, so if I start here, like at kind of at 0, and I go 1, 2, 3, 4, 5, and I end up at 6 again. So really 0 and 6 are at the same spot. 4, 5, 6. And then the other thing, just kind of want to go through an example, is like if I take 1 plus 3, that just gives me 4. So I start off at 1 and I go down 3, I end up at 4. No big deal. But what happens if I have 5 plus 3? That gives us an 8, but we don't have an 8 on a 6-hour clock. I've only got 0 through 5. So if I start off at 5 and I went 3 more, 1, 2, 3, I'd end up at a 2. So the easy way to do this is to just say, if the number you get is larger than the clock, so in this case a 6, then 8 minus 6 would give me the 2 that I need. Okay, so let's go over here and fill in our clock. Like I said, a lot of them, the first row here, 0 through 5, no big deal. 0 plus 0 is 0, 0 plus 1 is 1, 0 plus 2 is 2, 0 plus 3 is 3, plus 4 and plus 5. Again, the lower number, that's not going to be a problem. Now I go with my ones, and I'm going to 1 plus 0, that's going to be 1, 1 plus 1 is 2, I get 3, 4, 5, and then when I have 1 plus 5, like I said, that equals a 6, but we can't have a 6. 6 is also equivalent to 0, so 0 goes in here. Okay, next row. So I've got 2 plus 0, that's going to be 2. 2 plus 3, I'm sorry, 2 plus 1 is 3. 2 plus 2 is 4. 2 plus 3 is 5. And now I've got 2 plus 4 is a 6. But again, we don't have a 6. 6 is going to be replaced with a 0. And then 2 plus 5 is a 7. But again, 7 would be all around the clock once and then back at 1. And it's going to continue this pattern. So notice like each row we have 0 through 5, and they're in order. 0, 1, 2, 3, 4, 5. The next row we still have all those digits, but we kind of start at a 1, go through there. The next row we start at a 2, 2, 3, 4, 5. Then we kind of flip over on the clock, so 0 and 1. But again, it's 0, 1, 2, 3, 4. So it's going to continue this pattern. So once you see the pattern, you could just sort of fill it in. 3, 4, 5. And I don't have a 6, so it's 0, 1, and 2. Now 4 plus 0, so I start at 4, 5. I don't have a 6, it's 0, 1, 2, 3. And again, notice I have 0 through 5 in every row. And then the last one, 5 plus 0 is 5. 5 plus 1 is 6. But remember, 6 is also 0. And then we get 1, 2, 3, and 4. So here's our completed 6-hour clock. Again, I would recommend that you maybe draw a clock to help you figure out any that go above 6. 21 and 22 both use this table to figure out these this new math, right? So one of our operations is triangle. So I want to know D triangle C is equal to what? So I've got D. This is my triangle chart. So I got D, and then C is here. So where do these two interact? Boom, right here at B. So D triangle C is equal to B. On 22, we're trying to again figure out what X is. So something square E is equal to C. So something with E, so here's my E column, is equal to C. So what did E have to combine with to get C? Boom, right here. So D square E will give me back RC. So the answer in this one is D. Write the first 6 terms of the arithmetic sequence with the first term a sub 1 and the common difference of 4. Okay, now we're told that this is an arithmetic sequence, which means that we're adding the same quantity each time. I say adding, I mean it could be subtracting. It depends on the sign of the common difference. So in this case here, the common difference is a -4. So you might want to think of it as of subtracting. Okay, so the first term, we're given that one. It's 12. So to get to the next term, you're going to add your common difference. So 12 plus a -4, this will give us 8. Okay, so my third term, I'm going to take the previous term, 8, and then add the common difference again. So subtract 4. We get 4. For the fourth term, again, I'm going to take the previous term, subtract 4, we end up with 0. My fifth term, take the previous term as 0, subtract 4, we get a -4. And now for the last one, I have a -4 minus 4 gives me a -8. So here's a list of the first 6 terms of this arithmetic sequence. If we were told it was a geometric sequence, we would be multiplying by this common ratio to get the next term. Write a formula for the general term for the nth term of the arithmetic sequence. Then use the formula to find a sub 20. Okay, so if I just have to find a sub 20, I could use my formula. A sub 1 is equal to, a sub n is equal to a sub 1 plus n minus 1 times d. This is how I find the nth term for an arithmetic sequence. Okay, so again, if I just wanted to find a sub 20, I could say, oh, all right, so a sub 20 is equal to my first term, which is a 1, plus n minus 1, so we want to find the 20th, so 20 minus 1, and then my common difference. Notice that I'm adding 3 each time, so times 3. So I'd have 1 plus 19 times 3. So we'd have 1 plus 57 or 58. Okay, so again, that would just give me the 20th term, but we're asked to go ahead and find the general term, the nth term. So I'm going to use the same formula, except for this time n is not going to be 20. This time n is going to be n. N is equal to n. All right, so a sub n is going to be equal to my first term, which we know is 1, plus n minus 1. Again, n is going to stay n. And my common difference, we said, was a 3. Now I need to simplify this. So on the right-hand side, I've got 1 plus, now if I distribute, so that's going to be 3 times n, and then 3 times a -1. And if I have any like terms, I need to combine them. So I have 3n, and then 1 minus 3 is minus 2. So here is the formula for my nth term. I can also use this to find the value of any term. So if I wanted to find a sub 20, it'd be 3 times 20 minus 2. So 60 minus 2, which is 58. Same thing I got doing it the other way. Okay, so again, if you're just supposed to find a specific term, you can plug it right into here into this formula. But if I asked you to find the nth term, that means you're going to have to let n be n. I'm looking for something like this. Okay. Find the indicated term for the geometric sequence with the first term a sub 1 and the common ratio of r. Okay, so this time we're told that it's a geometric sequence, which means we're multiplying, to get the next term, we're going to multiply by the common ratio each time. So our formula is given by a sub n is equal to a sub 1 times r to the n minus 1. Right. So in this particular case, we have, we want to find the sixth term. So a sub 6 is going to be equal to a sub 1. We're given a sub 1 is 14, so it's 14 times r to the n minus 1. So r is 1/2, so 1/2 to the n minus 1, so 6 minus 1. So that means we have 14 times 1/2 to the 5th power. There's a couple ways of doing this, but I'm just going to say 14 times, and then 1/2 to the 5th power is, 1 to the 5th power over 2 to the 5th power, so we get 1 over 32. So that's going to be 1 over 32. Now if I multiply my fractions across, I get this here. You do need to reduce your fractions. 2 will go into each one evenly, so we end up with 7 over 16. So that'll be the sixth term for this geometric sequence. Again, it's important whether it's geometric or arithmetic because we use different formulas. You are offered a job that pays $20,000 for the first year with an annual increase of 8% per year beginning in the second year. That is, beginning in year 2, your salary will be 1.08 times what it was in the previous year. What can you expect to earn in your 7th year on the job? Round your answer to the nearest dollar. Okay, so first, what they give us a big hint right here, and they said, use the formula for the nth term of a geometric sequence to solve this problem. Okay, so that's huge. That tells us exactly which formula to use. Now that formula is a sub 1 is equal to, a sub n is equal to a sub 1 times r to the n minus 1. This will give me the nth term. So we need to first figure out what a sub 1 is, and we are told that in the first year you're paid 20,000. So a sub 1 is equal to 20,000. We also need to know what the common ratio is. What are we going to multiply by each time to get the next term? Well, my salary is going to increase by 8%, so you need to multiply by 1.08. So R is equal to 1.08. All right, so now I just plug them into the formula. And then also we want to know what to expect in our 7th year, so we're looking for a sub 7. So a sub 7 is equal to my a sub 1, so 20,000. My common ratio, 1.08, and then raised to the, 7 minus 1, so raised to the 6th power. All right, so I'm crunching this into my calculator. I'll get 20,000 times, when you take 1.08 and raise it to the 6th power, you're going to get a bunch of decimals. So I get 1.5868. It keeps going. Don't round those off yet. Multiply it by your 20,000. Now I've got 31,737 points. Let me clear out those decimal points for a little bit. So 48646. They keep going. All right. And then I was instructed to round my answer off to the nearest dollar. So I will round this off to $31,737. And this will be my final answer here. So again, we used a geometric sequence and we were finding the 7th term. Number 42, we're supposed to find the indicated sum. Okay, so this notation here means I want the sum of the first 14 terms. So if I were to list out all 14 terms and add them all together, what do I come up with? Okay, so I need to go ahead and figure out which formula to use. So the first thing I got to do is decide if it is arithmetic or geometric. So what's the pattern? When I go from 5 to 15, well, maybe I'm adding 10, maybe I'm multiplying by 3. How about when I go from 15 to 45? Adding 10 doesn't work, but multiplying by 3 does. So this is going to be a geometric formula or geometric sequence, right? And my first term is 5, and my common ratio is 3. I multiplied by 3 each time. So now that I know it's geometric, I know which formula to use. So my sum formula, so sum of n, is going to be equal to a sub 1, the first term, times 1 minus r to the n, and then all that is over 1 minus r. We can't do any canceling right now. We've got to plug in our numbers, crunch it out in our calculator. The order of operations is important. We need to make sure we do the exponents before we subtract or multiply or do the division. All right, so for my sum of the first 14 terms, I have a sub 1, which you said was 5. 1 minus common ratio is 3, so 3 to the 14th term, or 14 power, and then it's all over 1 minus 3. Okay, so now simplifying this, again, I have to do my exponent first. So I got 5 times 1 minus, so 3 to the 14th power in your calculator. I get 4782969, and that's going to be all over 1 minus 3 as a negative 2. I'm going to go ahead and simplify my numerator. So the 1 minus 4782969 is going to give me a negative, and then I'm going to multiply it by 5 too. So I'm going to get the negative 23914,840, and divide that by the negative 2, and I will have a grand total of 11,957,420. So that's the sum of the first 14 terms. Okay, so again, just to summarize, key to solving this problem, recognizing that we're looking for a sum and choosing the correct formula. Okay, before you can decide which formula to use, you really need to know if it's arithmetic or geometric. So that's when we looked at the terms.